What happens when Google drops a 100% open source AI model that runs on your phone? Here's how it changes everything. Here's why this matters. You've got all these models floating around: Llama, GPT-OSS, Kimi, DeepSeek, Qwen, Mistral. They all call themselves open, but every single one comes with some kind of catch hiding in the license. Gemma 4 sits right at the center of this ecosystem, and it's the only one that's truly, completely free. Apache 2.0. No revenue caps, no special deals you have to sign, no terms that change when you start making money. That's not a small thing, because every other option out there comes with strings you might not see until it's already too late. Let me break this down. Meta's Llama is free to use right up until you cross the revenue threshold. Then you need to go back to Meta and cut a commercial deal. That's not freedom. That's a free trial with extra steps. OpenAI shipped their open models under Apache 2.0, which sounds great on paper, but those models are both bigger and dumber than what Google put out. Then there's the Chinese ecosystem: Qwen, Kimi, DeepSeek. Really strong models, no question, but a lot of teams won't put their core products on top of them for compliance reasons. Gemma 4? Use it, change it, sell it, ship it. Nobody asks questions, nobody takes a cut. But the license isn't even the wild part. Look at where these models land on a size versus intelligence chart. Gemma 4 sits way down in the bottom right, small in size, high on smarts. Every model that scores this well needs way more hardware. Kimi K2.5 is up in the top right, smart, sure, but absolutely massive. Gemma 4 has 31 billion parameters and matches Kimi on most benchmarks, but the gap in what you need to run them is almost laughable. Gemma 4 is a 20 gig download. You throw it on one RTX 4090 and you're getting about 10 tokens per second. That's fast enough to build real apps with. No cloud account needed, no API key, no monthly bill at all. Now try doing the same thing with Kimi K2.5. You'd need over 600 gigs of downloads, at least 256 gigs of system RAM, more than one H100 GPU just to load the weights into memory. And even after you get all of that set up, it's still going to be slow. Kimi might score a bit higher on certain benchmarks, but you will never run it at home. Gemma, 5 minutes and you're live. And when you zoom out and look at the full picture across the things that actually matter: speed, size, freedom, intelligence, cost to run, Gemma 4 dominates the shape of this radar. It's not the smartest model on every single benchmark, but it wins so hard on everything else that the gap doesn't matter for most real-world use cases. You can run it, you own it, and you can ship real products with it today. That combination just didn't exist before at this quality level, and honestly, for most developers, that's all that matters. And the edge models push this even further down the size ladder. Some Gemma 4 variants have an E in the name: E2B, E4B. That stands for effective parameters. These models flow through a quantization pipeline and come out small enough to run on your phone, on IoT sensors, even on a Raspberry Pi. Just 2 years ago, you needed a full rack of data center GPUs for this level of AI. Now it fits on a board that costs $40. Think about what this unlocks: robots that think on their own, offline tools, apps that work where there's no signal at all. The AI runs right there on the device. No cloud call needed. So the big question: how is any of this even possible? How do you take something that used to need a whole data center and make it run on a phone? It starts with how Google rethought the basic architecture. In a standard transformer, you've got layers stacked on top of each other. A token goes in at the bottom, gets one embedding, and that same embedding rides through every single layer all the way up to the top. Most of those layers are dragging around data they don't need. That's where all the waste hides, and there's a lot of it. That's exactly what Google went after. The fix is called per-layer embeddings. Instead of one code riding through every layer of the network, each layer makes its own fresh code for each word. The right info shows up at exactly the right time. Nothing gets dragged along just in case. Nothing gets wasted. It's a simple shift in how the model handles data, but the savings add up fast across billions of parameters. And the wild part is that this one change is the main reason Gemma 4 can be so small. The second trick is called TurboQuant. Normally, when you shrink a model, it gets dumber. That's the trade-off everyone accepts. TurboQuant breaks that rule. It takes the weight data and converts it into polar coordinates, angles, and distances. Because those angles follow patterns you can predict, the model gets to skip extra math steps and store data way more tightly. Then it crushes everything down to simple sign bits, +1 or -1, using the Johnson-Linden-Strauss transform. The math behind it is dense, but the result speaks for itself. Smaller models that don't lose their smarts. And these aren't just papers, these tricks are in the models you download today. And here's where it gets real. You can take this model and make it yours. Install Unsloth, point it at your own data. In about 12 minutes on a single GPU, you've got a fine-tuned model that knows your domain, your style, your use case. No cloud needed. No per-token charges piling up. No vendor lock-in of any kind. The model runs on your machine, trained on your data, and you own every bit of it. Look, the impact here is massive. Smart, small, free. And now you can fine-tune it in minutes. No cloud bill, no license fee, no hidden clause that kicks in when you start making real money. Nobody changes the terms on you at 2 in the morning. Google gave the open source world something truly rare, a model that competes with the heavyweights, runs on hardware you actually own, and costs nothing to use forever. But honestly, the most exciting part isn't the model. It's this curve right here. The cost to run real AI locally just fell off a cliff. When anyone with a phone or a $40 Pi can run a competitive language model with zero friction, that's when things get truly wild. The question isn't whether Gemma 4 is good enough. It clearly is. The question is what you're going to build with it.